This is a screencast of a homework problem involving sand. I took a picture of a piece of paper with my phone. I wrote it out on paper and I took a picture of it with my phone. I'm viewing the picture on my computer and recording from Screencast-O-Matic on the web. Uh, it involves grains of sand of a given radius r. I'm going to solve in terms of the variable r, not in terms of the number. And it asks what mass of sand will have the same surface area as a cube of a given side length. And so my particular version of the problem had a side length of 1.9 meters, but we'll solve it in general for any sand grain radius r and cube side s. So the first thought that I have is, what is the surface area of that cube? And it's 6s squared, because each of the 6 faces of the cube has an area of s squared. How many grains does it take to have that amount of surface area? I've defined a variable n. If I have these 3 lines here, it means is defined as, so I'm just saying n grains of sand is the number of grains of sand that will have that surface area. Well, if you have n grains of sand and they have the same surface area of the cube, then you're saying n times the surface area of each grain of sand is equal to the total surface area of the cube. Each grain of sand has a surface area of 4 pi r squared. So n times 4 pi r squared is 6s squared. That's just saying the surface area of the sand grains, all n of them, has the same surface area as the cube. Now, solving for n, I see that n is 6s squared over 4 pi r squared. Okay, now what is the mass of that many sand grains? That's what the problem is asking. Well, it's equal to the volume of those grains times the density of them. The problem says that 2,600, that a meter cubed of silicon dioxide has a mass of 2,600 kilograms. So the density, the Greek letter rho here, is 2,600 grams per meter cubed. I can find the mass of all n grains of sand by taking the volume of them times the density of the material. The volume of n grains of sand is n times the volume of each grain of sand, and each grain of sand has a volume of 4/3 pi r cubed. And we said that the density was rho. That's sort of a given of the problem. Substituting our value for n, which was 6s squared over 4 pi r squared, we get some algebra, we do some cancellation, and the next thing that I like to do is to check my units and make sure that my units work. Do the units here work? Exploring that feature. How am I going to get this? Okay, so it turns out I had to resize my window in order to be able to show you the rest of the solution. This is what I think the answer to the question is, 2s squared r times rho. And so I want to check that that has the units that I want. The question asked about mass. Does this have units of mass? Well, this has units of s squared, and s is a length, so units of meters squared, times r has units of meters, times rho has units of kilograms per meter cubed. And meters squared times meters times kilograms per meter cubed does have units of kilograms. That's what I want. Great. So I substitute the values here, and I'm done. In my problem, 1.03 kilograms of sand would have the same surface area as a meter cubed of the material, which is pretty cool.